Classification of magnetic materials based on the existence of permanent dipoles and their orientation. Permanent dipoles and their orientation. Magnetic materials are classified into 5 categories. One is diamagnetic material. The second one is paramagnetic material. Third one is ferromagnetic material. Fourth one is antiferromagnetic materials. And the last but not least is ferrimagnetic materials. These are classified based on the permanent dipoles. Dipole means a system is consists of two equal and opposite poles separated a fixed distance is called dipole. The dipole momentum is the pole strength into the distance between the two poles is called dipole momentum. When a magnetic field is applied to an atom, the motion of the orbital electron gets modified in such a way that the weak magnetic momentum opposing to the magnetic field is induced. This type of nature is diamagnetism. When a magnetic field is applied to an atom, the motion of the orbital electrons in this material gets modified in such a way that the weak magnetic momentum is opposing to the field is induced. Diamagnetism is the result of this interaction. It is a weak effect and existing only in the presence of an external magnetic field. Materials which are weakly magnetized in the direction opposite to the applied magnetic field. These materials are called diamagnetic material. This phenomena is called diamagnetism. In this material, in this type of materials, dipoles are weakly magnetized opposite to the applied magnetic field. These materials are repelled by the magnets. In this type of diamagnetic materials, there is no permanent dipole momentum in this. That means magnetic effects are very small because there is no permanent dipoles in the type of materials. The lines of force shows less preference to pass through these substances than through vacuum or air. There is no permanent dipole momentum in this type of materials. Due to these, magnetic effects are very less. And the next one, the lines of force shows less preference. This preference to pass through these substances than air and vacuum. This type of materials. The susceptibility of these materials is negative. It's independent on temperature also. This type of materials independent on temperature. And also magnetic field strength. Examples like copper, gold, bismuth, antimony, mercury, some type of semiconductors or pure semi-intrinsic semiconductors, silicon, germanium, gases, helium, neon, argon, water, air, hydrogen. These are the diamagnetic materials. These are the diamagnetic materials. Diamagnetic materials. When a magnetic field is applied to an atom, the motion of the orbital electrons get modified in such a way that the weak magnetic momentum opposing the field is induced. Field is induced. Opposing field is induced. Diamagnetic materials is the result of this type of interaction. It is a very weak effect and exists only in the presence of an external magnetic field. Suppose there is no external magnetic field, this effect is zero. So only in the presence of external magnetic field this behavior arises. Means dipoles are oriented opposite to the applied magnetic field. A little bit. It's a very weak effect. Exists only in the presence of external magnetic field. Materials which are weakly magnetized in a direction opposite to the applied magnetic field is called magnetic materials. This phenomena is called diamagnetism. These materials are repelled by the magnets. In these materials, there is no permanent dipole moment. Due to this, magnetic effects are very small because you need permanent dipole momentum. Otherwise, the type of materials are not magnets. The lines of force shows less preference to these materials than air and vacuum. The susceptibility of these materials is negative, means negative value, and also these materials independent on temperature and also magnetic field strength. Examples: copper, gold, bismuth, antimony, mercury, intrinsic semiconductor like silicon, germanium, some gases, helium, neon, argon, and mixed with water, hydrogen. These are all diamagnetic. The diamagnetic material. In this dipoles are a few dipoles in this material. These dipoles, this material is placed in a magnetic field. At that time, these dipoles are oriented. It's very weak. Means not exactly oriented to applied magnetic field. Very few dipoles are responded. These few are also very weak. That's why this effect is very weak in this very weak effect. It exists only in the presence of external magnetic field. Suppose you remove this external magnetic field, as usual, dipoles are randomly oriented in all possible directions.